Hello, network engineers. Are you excited to learn segment routing? I hope yes. So before starting segment routing, let's review how MPLS LDP is working. So like any other protocol, if you enable MPLS LDP on the interface, they will start exchanging hello packet. And guess what? Inside hello packets, they will exchange the router ID as well. So let's see the MPLS LDP discovery output, where we can see in front of interface transmit and receive flag. This flag indicates we are receiving and transmitting LDP hello successfully. Okay, we can see local LDP ID, which is our own router ID, and the LDP ID 2.2.2, which is the neighbor's LDP ID. Okay, once the router ID is getting exchanged, then it will create the LDP session on which interface. Can you guess? Of course, if they're exchanging router ID, they will try to exchange, they will try to create TCP session on the router ID itself. So if you see the output, show MPLS LDP neighbor brief, the P1 has created LDP session on 2.2.2.2 and P2 has created LDP session on 1.1.1. For extra knowledge, while sending the hello, the protocol using UDP 646, and while creating the session, the protocol is using TCP 646 as well. So network engineer, I have question for you. So let's say loopback 0 is the router ID. Let's say you are running IGP as ISIS between P1 and P2, and you have forget to advertise loopback 0 into the ISIS. So will they able to create TCP session? So I guess the answer is yes. Of course, no, because if they will not get the connectivity, they'll not able to create TCP session. If they'll not able to create TCP session, they'll not able to exchange the labels. Okay. So once they will create the TCP session, the next step is guess what? Exchange the labels. So by default P1 for all the directly connected interface on which we have enabled MPLS LDP and router ID, it will generate label 3, which we called implicit null, and send it to P2. So let's see the LDP binding output here. You can see local binding label is implicit null. So it has generated implicit null, which is if you capture the packet over this link, you will see this implicit null is label 3. Okay. And the same for P2. P2 is receive implicit null and for 1.1.1 from peer 1.1.1. Okay. So there are three phases. Let us recap. First is LDP discovery. Second is TCP session. Third one is LDP bindings. Okay, now let's understand the control plane. So let's create a scenario. Okay, let's create P1, P2, P3, and P4. Let's exchange the label. Let's exchange the customer prefix, and let's see how LDP is working. Before that, let me continue what happens once the router receives the LDP binding. Okay, once router receives the LDP binding, it will populate the label into the LFIB. So LFIB is your final it's called MPLS forwarding table. It is your final table where traffic lookup happens. Uh, so this table contains incoming label, outgoing interface, outgoing label, next hop IP, IP prefix, and bytes switched. This column is missing. Okay, we can create scenario now. Let me quickly tell you about all this field. Incoming label or would be the label generated by the router. Outgoing label would be the label received by the peer, the LDP session peer. The outgoing interface, so we are receiving FEC, right? We are receiving prefix as well. So for that prefix, SPF algorithm will be run. So after SPF, the exit interface will be populated here. That's why we say LDP follows shortest path first. Next up would be the next hop IP for the same for the ARP resolution and the IP prefix. Let's say 1.1.1. the prefix for which it is generating the label. Okay, now I think we can create our scenario. So let's exchange the label between P1 and P4. Okay, so let's by default P1 will generate label 3 for all the directly connected routes and the router ID, but we will focus on the router ID only, which is 1.1.1.1. So network engineer, so P1 will generate which label for 1.1.1? If your answer is label 3, that is perfectly fine. So again, one more question. What is label 3 called? If your answer is implicit null, then it is also a good answer. Okay, so P1 has generated label 3 for 1.1.1 and advertised to P2. So what P2 will do, P2 in the LFIP table, P2 will place pop in the outgoing label and local label, it will generate a random label. So in this case, they have generated 24,000. And outgoing into how they derived gig triple zero. So they have run SPF for 1.1.1.1 and whatever interface came, it placed the same interface in the outgoing interface field. That is so simple. Okay. Now P2 has generated local label 24,000. So any guesses what P3 will place in LFIP table for 1.1.1 in the outgoing label field? If your answer is 24,000, that is absolutely right. So outgoing label, it will place 24,000 and for local label, it will generate a random one. So P3 generated 24,001. I think I don't have to tell what would be the outgoing label entry in the LFIP table of P4, but still I'll tell it would be 24,001 and the local label will be generated randomly. So outgoing label is 24,001 and of and local label is also 24,001. It could be anything. Okay. So we have successfully exchanged the label for 1.1.1.1. Okay. Hmm. Now let's create our end-to-end scenario for which we are waiting. So let's say P1 behind P1 we have 10K customers and behind P4 we have ISP. Okay, so we are running BGP between P1 and P4 on their loopback or the router ID for which we have exchanged the labels. So P4 has the BGP neighborship with P1 loopback which is 1.1.1.1. So all these 10K routes is received by P4 from peer 1.1.1.1. Okay, and from respective ERF, the customer prefix has been advertised to the ISP. Now ISP is sending 10K flows with different towards different customers. So how so once the traffic will hit on P4, so P4 will look the SAF table and it will push two label. One is transport, another one is VPN v4 label. So since we are learning, our intent is to learn segment routing. We will no, we do not care about VPN v4 label. Okay, so let me tell you the logic of the SAF entry. So it will check I have received the customer route via 1.1.1 and then from MPLS LFIP it will it will it will it will look up into the LFIP table and it will push a label for 1.1.1 into the SAF table. So let's see what was the entry. Ah, okay, so let's see for 1.1.1. PE4 will push 24,001. It will check the outgoing label and push 24,001. See, I'm using push for P4. Okay, let's see. So the traffic will reach to P3 in the data plane, and it will first of all it will check layer 2 information, of course, and then MPLS label, and it will find 24,001. And 24,001 it will match, it will look the LFIB and match the local fib. So it will match with the 24,000, this entry 24,000 and 24,001 and 24,000. Now, what P3 will do, P3 will swap the label. So the traffic received with 24,001, it will swap with 24,000 and send towards P2. Now P2 again will check the LFIB entry, and it will match the traffic label with the local label, and then uh, it will pop the label, transport label. So P2 will pop the label, it will delete the label and send it towards P1. And P1 will receive the traffic with the VPN v4 label only. And by looking into the VPN v4 label, it will redirect to the specific VRF where customer is connected. Okay, so what is the point to note here? For 10K flow, we have only single LDP entries, single LFIB entry, right? That's why your MPLS core is BGP free core. In the core router, we don't need customers prefixes or the ISP prefixes. So we have reduced the consumption of resources in the core router, and we can place less resource hungry router in the core and save some cost. But really, it depends on the account stream of the company. Generally, they have the sales technique, uh, and we can end up buying anything. Okay, so this is how uh, the LDP is end-to-end LDP is working. Okay, the innovation was we have replaced 10K routes in our example with a single LDP entries and reduce the resource consumption. And resource or memory comes up with the cost. So uh, in short, we have reduced the cost of our network. Okay, this is done. This is done. Finally, let's start segment routing. Yeah. Okay. So like LDP, segment routing is not the protocol. In LDP, we have hello packets, we have TCP packets, but in segment routing, only the label will be exchanged with the help of ISI IGP updates. Essentially, an index value is sent, and each router independently calculates the corresponding label. Even we are not sending the label in the IGP update, but we will send an index value, which we are going to learn further, and each router will calculate the label by themselves. The operations of push, pop, and swap in segment routing remains the same as in traditional label switching. Uh, so LDP is not a traditional one. Till now, most of the service provider are using LDP only. Like LDP, segment routing also follows the shortest path. Okay. So if you are running LDP in your network and if you are running basic segment routing, in terms of data plane, there would be no different. Still, your traffic will depend on the cost of the link, metric of the link. Okay. However, its potential becomes evident when we explore segment routing traffic engineering's capabilities. Yes. So in order to uh, see the power of segment routing, we need to wait until we arrive to traffic engineering videos. The label generated by segment routing is also referred as an instruction. This instruction directs the traffic to follow the shortest path. So we have new terminology in segment routing. We can call label as an instruction as well. And what instruction? Instruction is to follow the shortest path. Okay. So let's bring the segment routing in our network. See, before proceeding, I am considering we have a setup, a virtual setup or a physical setup where we can run and practice segment routing. I'm not creating a separate video for how to create a virtual setup because it is already available in the YouTube. So kindly search yourself. If you don't have the virtual setup, please prepare the virtual setup and then enjoy the segment routing course. Okay, so this is the example of iOS XR. Okay, so how can we run segment routing from the configuration perspective? So if you are running ISIS, we just need two knobs. We need to make sure MPLS style wide is configured, and we need to enable segment routing MPLS inside address family IPv for unicast. Okay, if you are running OSPF, then inside OSPF hierarchy, we need to run segment routing MPLS. Okay, so by default, it will enable segment routing in all the area. And if you want to enable for the particular area, you can go inside the one where you want to disable it. Okay, so once you enable, so let's take the example of ISIS only. Once you enable the segment routing MPLS inside ISIS, so whatever interface are placed inside that ISIS instance, on all the interface, you will enable MPLS automatically. Okay. Then, once you enable segment routing, then you need to like loopback. We have consider loopback 0, right, in the router ID. So same way, we for one of the router ID on which we are going to run the BGP VPN for address family, we need to go to that loopback and we need to enable prefix it. Okay, and we need to give an index value. Uh, okay, so now, and this index value should be unique in each router. For example, on P1 we will give one index value 1. For P2 we will give index value 2. For P3 we will give index value 3 and so on. Okay. Now we know how to configure segment routing, uh, which is very easy. Enable, let's take the example of ISIS. Enable segment routing MPLS and then configure prefix it on inside the loopback. Okay, let's see the hierarchy as well. Make kindly make note. The interface loopback is inside router ISIS, not the physical loopback 0. Okay, with this, I would like to complete the today's session. Now it's homework time. So for homework, we can use this topology P1, P2, P3, P4. First, we can run LDP, okay, and see how the labels are getting exchanged between P1 and P4. We can take example of P1 or P4, whatever. Then I want you to remove MPLS LDP because if you and then I want you to enable segment routing. Okay, so I have not told how label will exchange in segment routing. So I want you to explore by yourself with the open observations. And if you can comment what are your observations, that would be really cool. Okay, and in the next video, of course, we will look how labels will get exchanged in case of segment routing. What is global block? What is local block? So we will see everything in the next video. I hope you enjoy this session. If you enjoy, please support me by subscribing this channel. The all comments would be appreciable. So any feedback would also be appreciable. Okay, thank you.